Welcome, folks, to the Miles Davis Lesson 31 Extravaganza. Lesson 31, using rates, ratios, and proportions. Rates, ratios, and proportions. Somehow all these things are related to one another. We got to start off with some vocabulario. Start off with these first three here today, and then we're going to do some grocery shopping. Make sure that I get all of that in there. A ratio, a ratio is a comparison of two things using division. It'll look like a fraction. Okay, a fraction bar, but that would mean division. Comparing two things using division. Like saying the ratio of girls to boys was 2 to 1. 2 over 1. And as long as you know that one's on top and the other one's on the bottom. Similar to a rate is a ratio that compares quantities measured in different units. This would be saying like, I got 5 apples for $2. You got apples and dollars. Those are two different things. Or 12 ounces of soda for 75 cents. You got ounces and cents. There's your rate. Then you've got a unit rate. That's a rate, a special kind of rate. You can see the word there, unit or uni. Rate whose denominator is 1. That'd be saying like three apples for $1. Just 1. 3 apples for $1. Or 30 miles an hour. Something like that. That would work. That would work too. They got some examples in the thing there. They say like $2.50 per box, right? Or whatever, per car, something like that. But you got per one thing. Sometimes those are the most useful kinds, and then you can like scale up or scale down from there. And then we're going to also talk about proportions. Proportions is an equation that shows that two ratios are equal to each other. And we're going to use those all the time in math and science. So get used to it. Okay? Learn to enjoy these kinds of things. First of all, let's talk about grocery shopping and finding unit rates. You ever gone to the store and they've got like two different sizes of Honey Nut Cheerios? They got like the 55-ounce box and they got like a 32-ounce box. And you're trying to figure out which one is the better deal. Well, if you didn't, you should. I mean, isn't like getting to go to the grocery store the most awesomest thing there is? Because you can like maybe slip some things in there or help mom push in the cart or something like that. You see weird people. It's pretty fun. Usually on that row where the thing is, there'll usually be a little label there that basically tells you what the price is per ounce so that you can compare it if you're not smart enough to figure it out yourself. So sometimes the thing is 55 ounces of this for $3.75 a better deal than 32 ounces at $3? It's hard to decide, and so unless you take a calculator or you got it on the phone or something, it might be a little bit hard to figure that out. So you take your 375 divided by your 55 ounces, and I got a per unit item here of it's 6.8 cents per ounce. 6.8 cents per ounce. The other one I said was $3 divided into 32 ounces, and that one comes out to be about 9.4 cents per ounce. So buy the bigger box. You can have 2 bowls if you want to, but typically there'll be a little label there that helps you compare the prices so that you know. I think they probably had to do that legally at some point of figuring out which was the better deal. Now, I want you to think about this. Sometimes it's about getting more per unit. Sometimes it's about getting less per unit. So be very careful when you're doing your problems to determine when they say which is the better buy. It may be that you're getting more cans or more boxes for a smaller amount of money. But they may turn that around and they'll say which one is faster, and then you're looking for a bigger number. So please read the problem and find out what it is that they're asking. Do they want the bigger thing or the smaller thing? Which one is going to be the better thing? Secondly, converting rates. Well, we've dealt a little bit with conversions, I think, and you do have some tools. They usually put conversions in the back of those old peachy folders and whatnot. So you got some of those there. But the question in the book is about a bus driver driving at 30 miles per hour, and they want to know what would that be in miles per minute. Okay, miles per hour to miles per minute. I'll take 45 miles per hour, and we want to go to miles per minute. That is, the hour business has got to change. Well, there's more minutes than there are, that's equal to 1 hour. So you're not going to go as far in a minute as you would in an hour. Your answer should end up being smaller than 45. We're going to use a unit rate thing here. We're going to use the fact that that 1 hour is equal to 60 minutes. And we put the thing we're going from on the top and the thing we're going to on the bottom. That way those hours cancel out, and we're looking at now, well, it's 45 over 60, and then we've got miles on top, and we've got minutes on the bottom. And that ends up being 3/4 of a mile every minute, per minute, divided by minutes. They'll give you various things like that, but it would be a good idea to estimate or take a guess as to what type of answer that you will get. On that one in particular, I said you're not going to get as far in a minute as you do in a mile, so your rate will end up being much smaller. Could be the other way, and your rate gets much bigger. Please, put on your thinking cap, and when you get your answer, ask that question, is this a reasonable type of answer to get? They have another one about an engineer opening a valve that drains 60 gallons of water per minute. They want to know how many quarts that is per second. You've got two things to change there. And so please pay attention that both of those units have to be changed, but you can only do them one at a time. So you're going to need 2 unit conversion rates in order to make that change happen. First that they do is they go from gallons to quarts, and they change the top unit, and then they change that minutes to seconds so that they end up with quarts per second. Remember, make sure that you're going to be able to cancel out the unit that you want to get rid of and leave the unit that you're going after. So they got a pretty good explanation there of B. I want to move on to the next thing, but I got to clear my board first. Okay, I'm ready to go. I got my sticky notes ready. Success time. Here it is. You can see it in your book, but let's do it this way. You got your cross product property. It's an if-then statement, and it basically is just a very, very common operation that you're going to do in math with things, especially like ratios and whatnot. It involves what's called cross multiplication. And it's a little confusing because cross product is something that you do with matrices. But it's a similar kind of idea how things get paired up, okay? So if we got a fraction AB or a ratio A to B and another one C to D and they're equal to each other, then it is also true that A times D is equal to B times C. And A times D is equal to B times C. And so what we do there is we're going to multiply the A and D together, and then we multiply the B and C together. They cross that equal sign to multiply by that opposite term. And this is just doing the same thing to both sides. If I wanted to move that D to the other side, I could multiply both sides by D, and the D would end up here next to the A. And if I wanted to move the B to the other side, I would multiply both sides by B, and it would move over there next to the C. So it's really nothing fancy. It's no trick. It's just do onto one side as you do into the other. And let me just demonstrate this, that there are all kinds of other possibilities that would be the case too that don't end up looking like cross products. And that would be, let me just set this up here. Remembering that that equal sign is kind of like the go-between here from one side to the other side. I call this sticky note math. See if you can figure out why. That if I want to move any of these 4 items to the other side of the equation, I have to travel through the equal sign. So if it's a denominator, to get to the other side, it has to move into the numerator. If it's a numerator and I want it moved to the other side, it has to move through the equal sign to the denominator. So look at all the things that are actually equal to each other. I could just do the cross product and get this. AD or DA equals BC or CB in the numerators. That's true. But I could also move this over here and have D equals C times B over A. I could move this back over here and have D over B equals C over A. That's just the inverse of some of these other things. What else could I do? C is equal to dA over B. If I want to solve for B, I could have that. Every time I move something, it just went from the denominator over here to the numerator over here, or vice versa, numerator to denominator through the equal sign, crossing through the equal sign. Now, in order to see that this is true, what I'm going to do is I'll put up some actual numbers here. 1/2 is equivalent to 2/4, or the ratio 1 to 2 is equivalent to the ratio 2 to 4. All right? So let's do the cross product. 2 times 2 equals 1 times 4. Is that not true? Yes, it is. Of course it's true. How about this? Is 1 equal to 2 times 2 divided by 4? Yes. Yes, it is. How about 4? Is 4 equal to 2 times 2 divided by 1? Yes, that's true as well. So you can just move those pieces however you want to in order to get all these different things that are equal to each other. Now, what they'll typically do in the book is they will leave one thing as an unknown, like this. And they'll say, what is A? And one quick way to do that would be to take the cross product and turn this problem into 4 times A equals 2 times 2, and then finish it off by using division. A must equal 1 in that case. Or you use sticky notes and just move that A to the top and move everything else to the other side. 2 times 2 divided by 4 is A. I like using the sticky notes. They're pretty easy to manipulate as long as you're crossing through the equal sign to move it to the other side. So they're going to have several different forms of these proportional types of problems. The one that they have in the book is x is to 15 as 2 is to 3. And maybe you can figure that out in your head, but you can do a cross product of 3x is equal to 30. And then, so x must be 10. Let me clear the board. We'll look at like maybe one more kind of problem before we're done here. Right? Problem here is, if you got a classroom where the ratio of boys to girls is 3 to 2. The ratio of boys to girls is 3 to 2. And there are 25 kids altogether. How many boys and how many girls are there? The key to a type of problem like this is to compare the ratio of boys to the total in the ratio. And that's just taken by saying, well, for every 3 boys, there's 2 girls. So that's groups of 5. So if we compare the ratio here of boys to the total there, we should be able to get the actual number of boys to the total number of kids in the class. Same thing with the girls. The ratio of girls to the total in the ratio is 2 to 5. And then we're going to compare that. Let's put a G for girls here. compared to the total number of kids. Cross multiplication,